Yes, my dear students of 10th standard. So nowadays we are discussing about the periodic classification of elements, Unit 8 of your science book, which is a chemistry portion. So now we are going to move to the next topic, how to extract aluminum from its ore. That we are going to study now. Before that, I would like to ask some question to check your level of understanding in this chapter. Simple questions. First question: who prepared the modern periodic table? Who prepared the modern periodic table? As you know that it is Henry Moseley, a British scientist, devised the modern periodic table based on the increasing order of atomic number. Then, what is called a modern periodic law? What is called a modern periodic law? So it is nothing but the physical and chemical properties of the elements are the periodic functions of their atomic number. And what are periods? The horizontal rows in the modern periodic tables are called periods. And how many periods? There are 7 periods. And what are called groups? The vertical columns in the periodic table starting from top to bottom are called groups. There are 18 groups in the modern periodic table. Then, what are inner transition elements? So, lanthanide actinides, which are in group 3, are called inner transition elements. Then, what is called periodic? Anything which repeats itself after regular interval, that is called periodic. This behavior is called periodicity. Then, atomic radius. What is called atomic radius? It is the distance between the center of the nucleus and the outermost shell containing the valence electron. And there are two types of atomic radius: covalent radius or metallic radius. Metallic radius, which is in metal atoms, and it is nothing but the half the distance between the nuclei of adjacent metal atoms. Then covalent radius, that is nothing but which is mainly non-metallic elements, half the distance between the nuclei of two covalently bonded atoms of the same element in a molecule. Example, hydrogen. Then what is called a ionic radii? It is the distance from the center of the nucleus of the ion up to the point where it exerts its influence on the electron cloud of the ion. And there are two types of ions. You know that cations and anions. Cations are positively charged ion. Anions are negatively charged ion. And cation is always smaller than its neutral atom, but anion is larger than its neutral atom. Then what is ionization energy? The minimum energy required to remove an electron from a gaseous atom in its ground state to form cation. This is called ionization energy. Then next one, what is called electron affinity? That is nothing but the amount of energy released when a gaseous atom gains an electron to form an ion. Then electron negativity, this is nothing but it is the tendency of an atom to attract shared pair of electron. Tendency of an atom attract the shared pair of electron. Then next one, already we learned about we started the metallurgy. So metals are very important and play a very vital role and also take part in the metabolical activities. Example, sodium, potassium, calcium, iron. And we know metallurgy, that is nothing but that is the extraction, it is the science of extraction of metal from their ore. Science of extraction of metal from their ore. And in this there are some steps. First, concentrating the ore, protection of metal, refining of metal. Then there are some terms, terminology in metallurgy are given. The terminologies are nothing but that is what is called mineral. That is the compound or complex mixture obtained from the earth crust. Ore, the mineral which is ready to extract metal economically on large scale. That is called ore. Then mining. This is nothing but the process of extracting the ore from the earth crust. Gangue or matrix is the impurity, rocky impurity associated with the ore. Then flux, that is the chemical substance added to the ore to reduce the fusion temperature. Smelting is the process of reducing metallic oxide to metal. Then slag is nothing but which is obtained when flux react with gangue. The next also we have discussed about the types of separation or concentration of ore. The first one, see, hydraulic or gravity separation. This is mainly for the oxide ore. This is mainly for the oxide ore like bauxite, copperite, hematite. And what is the principle of this hydraulic method? The difference in the density or specific gravities of the ore and the gangue is the main principle. Difference in the density or specific gravity between ore and the gangue. Then next one, magnetic separation. So what is the main property? That is the element, the ore particle which possess the magnetic property like a tin oxide can be separated from their impurities using this magnetic separation method. Then froth flotation. What is the basic principle of froth flotation? That is the wettability of the ore with the pine oil and gangue with the water. The wettability of the ore with the oil and gangue with oil. So the lighter ore like a sulfide ore, galena, iron pyrite, zinc blende, these ores can be separated using this froth flotation, and the impurities are settled, which are heavier, so settle at the bottom of the froth flotation tank, that can be removed. Next, chemical method. This is more or less used to for the purification of more pure form of ore. Then also we have learned about the occurrence of ores in Tamil Nadu and properties of metal. Properties of metal that you know very well. Physical state, that is hard and solid, highly shining, and high melting and boiling because of the close bonding of atoms between the metal atoms. Then their densities are high and they are having the property of ductility and malleability. They will not easily break and crack during the hammering. Then they are ready to conduct heat and electricity. Metals are good conductors of heat and electricity, and they will not easily dissolve in liquid solvents. These are some of the physical properties. Then what are the chemical properties? So metals more or less having the valence electron 1, 2, 3 in their outermost shell, and metals are ready to donate electron, lose electron, and by this way they are going to form positively charged cation. And the metals normally during the electrolysis process they discharge ions at cathode because they are positively charged particle. Then atomicity. The number of atoms in a molecule is normally going to be monatomic. Then metal oxides are normally basic in nature. They behave like bases. So my dear students, up to this already we have discussed. Now we are going to learn the new topic, that is extractive metallurgy of aluminium. Extractive metallurgy of aluminium. What is the symbol of aluminium? Al. Al. A should be capital, L should be small letter. Whenever you write symbol, first letter, suppose a two letter symbol mean first letter should be capital, second letter small. Suppose only one letter symbol mean that should be in capital. That already you have learned in 6th 7th standard. Now see the first introduction. Aluminum is the metal found most abundantly in the earth crust. It is a reactive metal obtained combined state. So in this para you have to underline three important terms. Abundantly obtained in the earth crust, that is existing in large quantity, and this is highly reactive element. So because of high reactivity, these metals will not obtain in the free state. In free state, they will always obtain in the combined state along with some other element. So what are the important ores? Ores, ores are the minerals which are used for the extraction of metal. Minerals are the substances which are obtained from the earth crust. You should know the difference between ores and mineral. Then there are three important ores of aluminium. Bauxite, formula Al2O3, 2 moles of water. Cryolite, Na3Al(F6), that is sodium aluminum hexafluoride. The name is sodium aluminum hexafluoride. Then corundum, that is aluminum oxide, Al2O3. So out of these three ore, these three are ore. These three can be used for the extraction of aluminum. But out of these three, bauxite is the chief ore. Bauxite is the chief ore because bauxite is obtained abundantly, and the metal proportion is more in bauxite compared to the remaining. So bauxite is selected as a chief ore out of these three ore. Then there are two important main steps to convert bauxite ore into aluminium. So bauxite is the chief ore. Now the bauxite is selected for the extraction, and first step C, that is a conversion of bauxite into alumina. Bauxite into alumina. The process name is Bayes process. Bayes process. And in this process, there are three important stages are there. There are three important stages. See, it is given, see the first para you have to consider as the first stage, second para second stage, third one third stage. See, first one, see, bauxite ore is finely ground and heated under pressure with a solution of concentrated caustic soda solution at 150 degrees Celsius to obtain sodium metaluminate. So simply you have to understand the first para illustrate bauxite into sodium metaluminate. That is the first step. That is a bauxite ore into sodium metaluminate. So in the presence of caustic soda at 150 degrees Celsius. So when bauxite ore is powdered and added with the sodium hydroxide, caustic soda means sodium hydroxide, at 150 degree, sodium metaluminate is formed. This is the first stage. Then second step, see, on diluting sodium metaluminate with water, aluminum hydroxide is formed. So second step, what is the heading? That aluminum sodium meta-aluminate to aluminum hydroxide. Sodium meta-aluminate to aluminum hydroxide. So the sodium meta-aluminate obtained in the first stage is dissolved, diluted with excess of water. What will happen? See, aluminum hydroxide is formed. Aluminum hydroxide in the form of precipitate is obtained. This is second step. Then third step, that is aluminum hydroxide to alumina. Aluminum hydroxide to alumina. So So this aluminum hydroxide precipitate is filtered, washed, dried and ignited up to 1000 degrees Celsius to get alumina. So formula for aluminum hydroxide is AlOH thrice. The 2 moles of aluminum hydroxide at 1000 degrees Celsius turn to alumina, Al2O3, that is aluminum oxide, also called alumina, with the 3 moles of water. So my dear students, the first step, that is the conversion of bauxite into alumina, Bayes process is used. The name of the process is Bayes process, and there are 3 stages in this. First stage, bauxite into sodium metaaluminate in presence of caustic soda. Second stage, that is sodium metaaluminate to aluminum hydroxide. Third stage, aluminum hydroxide to alumina. Aluminum hydroxide to alumina. See, actually for each stages equations are there, but only one equation is given for you, and it is enough for you to have to practice. 2 moles of aluminum hydroxide on heating 1000 degrees Celsius, alumina and water are formed. So this is the first step in the extraction of aluminum from bauxite ore. Then second step, so the aluminum oxide, that is the alumina obtained in the previous process, that is the Bayes process, is not pure one. It is not pure one. Still it contains some impurities. Oxide is there. So all these are going to be reduced. It's going to be reduced. The removal of oxygen. Removal of oxygen is reduction. So second step, electrolytic reduction of alumina. Reduction means what? Removal of oxygen from aluminum oxide. So the name of the process is Hall's process. The name of the process is Hall's process. Electrolytic reduction of alumina by Hall's process. And see, aluminum is produced by the electrolytic reduction of fused alumina in electrolytic cell. So for this process we are taking electrolytic cell, electrolytic tank. So in electrolytic tank, cathode, anode, electrolyte and passing electric current, temperature, all these are important. So first one, see which are used as a cathode. Iron tank, because the electrolytic tank is made up of iron. That iron tank, outside is going to be iron tank, inside is lined with graphite or carbon. Graphite means carbon. That graphite lining acts as cathode. Cathode means negative electrode. Then anode, that is a positive electrode. The bunch of graphite rods suspended in the molten electrolyte. So suspended electrodes are called anode. So what is the mixture taken in the electrolytic tank? That is called electrolyte. Electrolyte is the mixture which is taken for the reduction. So pure alumina obtained from the Bayes process, the pure alumina plus molten cryolite is added, fluorspar is added. So these three are taken in the electrolytic tank. These three are combiningly called as electrolyte. What are the things? Alumina, cryolite, fluorspar. Out of this, fluorspar is the substance which is used to reduce the fusion temperature. Then you can see the diagram here. See what is the temperature in the electrolytic tank? 900 to 950 degrees Celsius. The voltage supplied is 5 to 6 volt. The overall chemical reaction, alumina, 2 moles of aluminum oxide reduced to aluminum and oxygen. See the diagram here. See, there is in the electrolytic process of manufacturing aluminum. So this tank is made up of iron. That is called a steel shell. The outside is going to be steel, iron, but the inside is lined with the carbon, graphite. The carbon that act as a cathode. Then the suspended electrodes which are act as anode. So what is taken inside? The inside is the mixture of pure alumina, cryolite and fluorspars are taken. By the electrolytic process, by the electrolytic reduction, this aluminum oxide is reduced to aluminum. Aluminum oxide is reduced to aluminum in this process. Sometimes this diagram will be given and you are asked to label the parts. So diagram also important one and you have to go through. Then aluminum is deposited at the cathode and oxygen gas is liberated at anode. Oxygen combined with the graphite to form carbon dioxide. So the aluminum obtained in this process is going to be deposited at the bottom of the electrolytic tank at the cathode. The oxygen gas, oxygen along with the aluminum oxide liberated, which is going to combine with the anode and react to form carbon dioxide gas. These are the thing you have to learn. See, in the conversion of bauxite to alumina, there are 3 steps. First, that is bauxite into sodium metaluminate, then metaluminate into aluminum hydroxide precipitate, then aluminum hydroxide precipitate to alumina. Then electrolytic reduction, you should know cathode ion tank, anode bunch of graphite rod, electrolyte pure alumina, molten cryolite, fluorspar, then temperature 900 to 950 degrees Celsius, voltage used 5 to 6 volt, overall reaction 2 moles of aluminum oxide gives 4 Al aluminum plus 3 moles of oxygen, and diagram also you have to go through. Then what are the physical properties of aluminum? So physical properties are nothing but it is a silvery white metal. This is a shining metal and density low 2.7. So that's why it is going to be very lightweight, and it is malleable and ductile, can be converted into thin wire and thin sheet. Good conductor of heat and electricity. That's why we use in the manufacture of vessels and the electric cables. Melting point 660 degrees Celsius and can be polished to produce attractive appearance. Then chemical properties. See the chemical properties and early you have to write and practice in your notebook. Use your rough notebook to write and practice the equation. See, normally aluminum will not affected by air at ordinary temperature. At ordinary temperature, there will be no reaction between aluminum and air. But when you are going to heat the aluminum at 800 degrees Celsius, it burns brightly to form aluminum oxide. So 4 moles of aluminum with 3 moles of oxygen, 2 moles of aluminum oxide. Then similarly aluminum burn in presence of nitrogen to give aluminum nitride. Aluminum nitride when going to be heated. Then reaction with water. So aluminum also will not easily react with the water. If it is reactant, we cannot use it in the form of vessel. But when aluminum is allowed to pass over red hot steam, when steam is allowed to pass over red hot aluminum, steam with high temperature, aluminum at a red hot condition, in this condition that steam react with the aluminum to form aluminum oxide and hydrogen. So 2Al plus 3H2O. H2O means normally we use this is the formula of water, but steam, there is also a form of a state of water, H2O, steam, and steam react with the aluminum oxide and hydrogens are formed. Then next reaction, the reaction with the alkali. Alkali means sodium hydroxide, potassium hydroxide, that bases which are readily soluble in water, they are called alkalis. Then it reacts with a strong caustic alkali. Strong caustic soda means sodium hydroxide. So sodium hydroxide reacts with aluminum to form sodium metaluminate and liberate 3 moles of hydrogen. Also, aluminum reacts with the dilute and concentrated hydrochloric acid. HCl means hydrochloric acid and liberate hydrogen gas. So aluminum react with the 6 moles of hydrogen chloride HCl hydrochloric acid, aluminum chloride 2 moles of aluminum chloride and 3 moles of hydrogen is liberated. So aluminum liberate hydrogen and react with the dilute sulfuric acid also, and sulfur dioxide gas is formed when aluminum react with the concentrated sulfuric acid. So aluminum with 3 moles of sulfuric acid, aluminum sulfate and hydrogen. This reaction take place in the dilute condition of sulfuric acid. But at the same time, if you take sulfuric acid, that is concentrated, hot and concentrated sulfuric acid, aluminum sulfate, water along with the sulfur dioxide gas also form. Then see the more to know, dilute or concentrated nitric acid does not attack aluminum but renders aluminum passive due to the formation of an oxide film on its surface. So this is a question normally asked in the exam also. Why that nitric acid will not react with the nitric acid will not react with the aluminum? See, hydrochloric acid react with aluminum, sulfuric acid react with aluminum, but nitric acid will not react, because when nitric acid react with the aluminum, it's going to form an oxide film on the surface, going to form an oxide film. Because of coating of oxide film, there will be no reaction between acid with the aluminum. So aluminum will not be easily attacked by nitric acid. Then aluminum is a powerful reducing agent. It reduces iron oxide to iron. Powerful reducing agent. This is also important one. When mixture of aluminum powder, that is 2Al, treated with the iron oxide Fe2O3 is iron oxide. So when aluminum powder treated with iron oxide, that iron oxide Fe2O3 is reduced to iron Fe2O3 to Fe. So the oxygen 3 atoms of oxygen is removed. So the removal of oxygen is reduction. This reduction is done by aluminum. That's why aluminum is a powerful reducing agent. So oxide of iron is reduced to iron in presence of aluminum. And heat is liberated. So this is called aluminothermic process. And in this reaction, both the things are take place. Oxidation also take place, reduction also take place. That is Fe2O3, which is going to be reduced to Fe. Fe2O3 is reduced to Fe. That means what? Removal of oxygen. That is reduction. At the same time, we can take aluminum. Aluminum is oxidation. That is oxidation take place on aluminum. Al2O3. Aluminum to aluminum oxide. That is oxidation. So oxidation also take place. Reduction also take place. So this is redox reaction. This is called a redox reaction. And the next one, see, because reduction, oxidation, both the processes are simultaneously take place in this chemical reaction. Then uses of aluminum. So aluminum uses are, for example, household utensils. We use different types of vessels, and the electric industry it is used. Also it is a very light and malleable. It is used to prepare the aeroplane parts and other industrial machine parts, and there are also some other important uses also there. So only 3 points given, you have to go through up to this. So my dear students, the next one is extractive metallurgy of copper, that we will discuss next class. So you have to know, you have to learn this topic, but under all revise now. That is the extractive metallurgy of aluminium. Aluminum is abundantly obtained, highly reactive, so obtained in combined state. Important C4 is bauxite, formula Al2O3 to H2O, and there are two main steps: conversion of bauxite into alumina, it is called base process. Then The electrolytic reduction of alumina, that is called the Hall's process. And you have to learn about the diagram of the electrolytic reduction of aluminium from alumina. Diagram is important. Then physical properties: silvery white metal and malleable, ductile, good conductor. Then chemical properties: it will react with oxygen at 800 degrees Celsius to form aluminum oxide. Then also ordinary water will not react, but steam react with the red hot aluminum to give aluminum oxide. Then hot alkali react to form sodium metaluminate, and hydrochloric acid, sulfuric acid react to give concerned salt, aluminum chloride, aluminum sulfate. But nitric acid will not attack because it forms an oxide film on the surface of the aluminum. And next one, see, it is a powerful reducing agent. It reduces oxide of iron oxide to iron. It is the reduction property of aluminum. This process is called the aluminothermic process, and the uses are there. So my dear student, revise up to this thoroughly, and don't waste the time. You have to write and practice the equation. Take your rough notebook, equations and all you have to write and practice. Out of these chemical properties, one or two will be asked. For example, the aluminothermic process, reducing agent is important. Then also the property reaction with water, reaction with air. These things are often asked in the question paper, the examination point of view. Also, you have to go through the method of extracting aluminum from bauxite ore. That is important questions. So go through, prepare well, don't waste the time. And the next copper and iron we will see in the next session. Till that, be safe at home, and always continuously prepare, continuously study. Then only you will have interest upon learning. If you will be lazy and lethargic, you are going to lose the interest on the learning. Then it will going to enter your knowledge, acquiring knowledge. So thank you. God bless you.